Alright, this is our Mercedes kiln here. And I've been working on this vet. This kiln has both updraft and downdraft. So this is the updraft flue. And back here is the downdraft flue. Though both of them go up, the downdraft goes down before it goes up. Or the updraft just goes up, it doesn't go down. And so I retrofitted this to the kiln, which was the original design, and this is the damper slide on it here, which can be operated from down below. And some of this is unfinished. There's going to be some heat shielding up here. So that's the top of the kiln. Kiln is more or less airtight, sealed up with silicone cement. All these joints are sealed. We've got a CO2 sensor in the top as well as a barometer, and the CO2 can gauge the amount of, indirectly gauge the amount of carbon in the atmosphere in the kiln, which affects the glaze colors. This is a kiln called a top hat kiln because the stack is stationary and the kiln goes up and down. And the kiln has a lock on it, so mechanically, if you ever did have a cable failure, the lock would mechanically hold it up. So this is more or less full height. The pad of the kiln is castable refractory. The interior lining is 8" of 2600 degree refractory fiber. The outside is stainless steel shell, so you don't get any corrosion. And the shelf systems are called lug posts. And the lug posts are very handy because you can quickly change the setting of shelves. Right now there aren't very many shelves in, but the shelves go in by simply sliding them in and resting them on the lugs, so you can very easily change the setting of the shelves for different heights of wear just by putting shelves in and taking shelves out. And these are set into sockets in the floor, so you can have a shelf a ½ inch off the floor and then every 2 1/4 inches all the way up. The top of the stack is more or less right here. So it's a conveniently sized kiln. It's not huge and it's not really small. So right now it has a flue in the top, which is a hole right here, and then it's got a downdraft flue here. So by choosing which flue you use, you can direct heat either up or down in the kiln. This is a kiln pad. The pad is cast in 4 quadrants, and that's so you have a capacity for expansion and contraction without cracking. The castable is a high temperature refractory, but it's got a stainless steel crimped wire reinforcement that was mixed in with it. And on the surface it burns up, which is not much of a problem, but inside it, if the refractory cracks, the stainless steel reinforcement keep the cracks from propagating. They keep the pieces together. So this has a few cracks in it, but nothing substantial. So this step seals against the fiber, and then this is a piece of fiber gasket material that also seals. The kiln is fired with 16 burner ports. It's got one burner mixer firing 16 ports. So there's 4 ports on each side, and the ports are angled out so that they flare the flame against the fiber wall. This kiln is fired with one single burner, one single mixer, and this is the primary air on the mixer right here. And this feeds into a manifold, which is common to 16 burner nozzles. So you can make all of the air fuel settings at one source, and it affects all of the 16 burners. And the pressure and the gas volume going in is gauged on here. And you actually have 2 manifolds. You've got a pilot manifold, which is this one, and the main burner manifold, which is this one. So this reads the amount of fuel in terms of water column inches going into the pilot, and this reads the main burner. And all of this is hooked up to a flow volume meter, so that the amount of fuel used for each firing can be calibrated and recorded, so you know exactly how much fuel you're using and how much the cost of firing is. The mirror gives you a view up into the burner ports, which are under the kiln, and so by standing right here, it's equivalent to laying on your back looking up at the bottom of the floor. So you can see the color of the flame, and you can see to a certain degree the intensity of the flame. Takes a while to get around the manifold. Okay, I'm going to light the main ones. There'll be a little bit of a pop. And it takes a while until they light all the way around. Pressure has to equalize and so we don't have much primary yet, you see. And now I'm going to open the primary. Okay, you're seeing it. I'm not going to leave them burning a long time here. I'm going to shut the pilot. The pilots are making most of the racket. So we're going to go backwards here. capping part of them so I don't get back burns when I shut it off. So that's off. That's off. This is a kiln pad. The pad is cast in 4 quadrants, and that's so you have capacity for expansion and contraction without cracking. The castable is a high temperature refractory, but it's got a stainless steel crimped wire reinforcement that was mixed in with it. And on the surface it burns up, which is not much of a problem, but inside it, if the refractory cracks, the stainless steel reinforcement keep the cracks from propagating. They keep the pieces together. So this has a few cracks in it, but nothing substantial. So this step seals against the fiber, and then this is a piece of fiber gasket material that also seals.